Okay, Miss Marrero just did this. Mrs. Marrero just did this. But just to recap, everyone has on their warm-up sheet for this week, Monday, date written down, learning target written down, and then you wrote the problem and you solved it, right? You added 7 on both sides, and then 17 plus 7 is 24. To get rid of that 3, coefficient, you divided by 3. The colors are changing for no reason. And x equals 8. So you have all this written down on your warm-up sheet. And right here, I let you know the assignment from Friday, if you just do a little bit on the front, a little bit on the back, we're not going to belabor that assignment. I want to see you did something. So if you did part of the assignment on Friday, make sure you turn it in. Do you know where everything gets turned in? In this turn-in bin. See it? It's always right here. So if you have something late or on time, turn it in. Cool. So do that whenever you got it. And here we are. We are going to talk about this babysitting problem. Okay? Let's say you wanted to make some cash babysitting. Miss Castro needs a babysitter for a month, for 30 whole days. She has given you 2 options. Now think about this. Everyone has this paper, by the way? Okay, option 1 says you get paid what? What? $10,000? Is that a lot of money? Who said no? Okay, don't you wish you could get a babysitting gig getting paid $10,000? Okay, and then what? An additional $5,000 every day after. Okay? Sounds pretty good. What about option 2? You get paid what? How much is that? 1 what? Cents, right? On the first day, and each day after that you get paid twice, which means what? Times 2 every other day. Now, if you only work for 1 day, which one are you going to pick? Option 1. Duh. Okay? The question is the doubling going to make it? I mean, 1 cent is pretty low, 10,000 is pretty high. Will it ever even out? So what you're going to do with your yellow calculators, unless they're dead, you can get a new one or use your phone. But I want you to start filling this out based on that information. I'm going to help you get started. That's the one I said you could turn in. Yeah. Okay, so for number 1, we start off with how much? Write that down, 10,000. And then I'm adding how much? 5,000. So what would my next one be if I added 5,000 to 10,000? 15,000. What about the next one? Add another 5 to the 15, you get 20,000. And we'll do one more for fun. Add 5,000, I get 25,000. Could you finish off that table? So again, you're adding 5,000. On the right side, though, how much did we start off with? $0.01 or 1 cent. And if I double that times 2, what would the next one be? We're multiplying. 1 cent times 2 is 2 cents, 0.02. Double that. 4 cents. And then double that. 8 cents. Do you see how you're multiplying by 2? Multiplying by 2. There it is. Okay, so everybody, go ahead and fill in the table, and we'll see what happens near the end of the table. But do all 30 days for both sides. Add on the left, multiply on the right. How's everyone doing? Getting it down? Almost to the 30th day? Keep going. So check it out. When you filled it out, it should look something like this, okay? Now, if you're using a yellow calculator and you saw E6, E6 means the decimal gets moved 6 to the right, okay? E means times 10. The 6 tells you how many times you move it to the right. So basically, at the end of our first option, we get $155,000. That's a lot of money, right? Pretty good. But if we started with 1 penny and we doubled for a whole month, we end up with $5,368,710. $368,710. Okay. So obviously, which one is in the end going to pay more money? Option 2, right? Now that's if you work all 30 days. Now, if I asked you which one you want to work for one day, obviously, which one do you want to work for one day? Option 1, right? So about where do these options kind of meet is kind of around 24. So at 24, we have 125,000 here, and then 83,000 over here. The next one goes from 130,000 to 167,000. Makes a big leap. So between day 24 and 25 is when option 1 gives way to option 2 being better, okay? So everyone, make sure you got your table finished. I see some people finishing up, so I'll let you do that. All right, so everyone's finished the table. Let's still working on it. All right. So at least write down the last one. If you haven't finished it, why don't you go ahead and write down the last one? 155,000 on the left, and on the right, 5,368,710. On the back here, whoops. Okay, option 1 can be modeled by what? If you're adding each time, what kind of function is that? This was all last week. Everyone in this class should know this. If you're adding each time, that's linear. Okay? Let's fill that blank in by a linear function. Okay? Now, the reason why everyone has a calculator is because you need to learn how to do a regression. This is going to make your life a little bit easier. So does everyone have a yellow calculator that actually works? Make sure it turns on. Okay? So, again, everyone has a yellow calculator. Go ahead and press on for me. Focus. Your calculator's on. I want you to do a new document, okay? Okay, new document. Since we're going to be doing lists and spreadsheets, okay, go ahead and press number 4. And everyone should have a blank spreadsheet on their calculator right now, okay? Now, to figure out the equation, again, the way we did it, well, how about them Cowboys? The way we did it last week, where am I? The way we got an equation, it was like find the zero value, find the rate of change, right? This will be maybe a little bit easier if you like calculator and pressing buttons. Okay? What we need to do is take the first 3 days and put it into the spreadsheet. So we're going to put 1, 2, 3, and then 10,000, 15,000, 20,000. But you need to know the first step. Have y'all done regressions before? What's my first step that I can't forget? You got to label your lists, okay? So in A, go all the way up to A and put an X, and go to B next to it, put a Y. If you don't label X and Y, you can't do it, okay? So once I label X and Y, I'm going to go down to 1, put in 1, 2, 3. Day 1, day 2, day 3 are my X. And then for my Y, I started with $10,000 and then $15,000. Oops. And then $20,000. Now, did we say that's linear or exponential? Linear. So what I want to do is a linear regression. Okay? So I want you to think intuitively. Regressions are a statistical thing. So we're going to press menu to get to our options. And like I just said, it's statistical, so we're going to press 4 for statistics. And we're going to do a stat calculation, pressing 1. And then I need to pick which one is linear. Now, there's 2 linears, right? But we're going to pick 3, the mx plus b. A plus bx, don't worry about that. We're used to mx plus b, right? So 4, 1, 3. And remember when we labeled x and y? X needs to be x, type that in. Y needs to be y, type that in. If you don't label those, it's not going to work. But if you do, and you press OK, it'll give you a linear regression with mx plus b. It'll tell you m is 5,000 and b is 5,000. And this is really important. Is everyone looking right here? Does everyone see how it says r squared and 1? You know your regression is good if r squared equals 1. Okay? So for example, if this was actually exponential and I did a linear regression that doesn't match it, r squared would not be 1. So this kind of tells you if you're good. So again, r squared equals 1, good stuff. Now if m is 5,000 and b is 5,000, can I write mx plus b? I hope so. So let's go back to do that. Writing our equation. So y equals 5,000 x plus 5,000. Okay? And what did I press? Menu 4, 1, 3 for linear. You might want to make a note of that. That way, if you look at your notes, you're like, how did I do this? I did menu 4, 1, 3. I labeled X and Y. Boom. So we need to know what these mean. What does 5,000 mean right here? M means what? Okay. Slope, which is a rate of change. Which in this case is the money per day. $5,000 per day. Okay? MX plus B is also 5,000, but what does B stand for? Do y'all know this trick? B stands for beginning. It's what you start with. Okay, does everyone hear me say that? B for beginning. It's what you start with. So it's the starting amount, or the initial value. Okay? So if I gave you a bunch of different numbers and tables, could you do this to figure out the equation? Type them in with XY, menu 413, write the equation, okay? That's for linear. Now option 2 was multiplying each time. What's that called when it's multiplying each time? Can you teach them all that? Okay, exponential. Exponential. So again, we know it's exponential because it was multiplying each time. Have you done regressions like this on here before? Okay. So we're going to do the same thing. Instead of linear, we're going to do an exponential regression. So again, let's pick the first 3 points on the table, which are 1, 2, 3, 0.01, 0.02, 0.04. Okay? Everyone in the back with me? So let's write this down. Let's go to our calculator. I'm going to do a new document. So this is already like got stuff on it. I'll press on. Number 1 for new document. Do not save. Number 4 for list and spreadsheet. What do I got to do first at the top? Let's type this in. So X and Y go at the top, right? If you don't label it, it won't work. 1, 2, and 3. Okay, so we started with a penny, which is $0.01, doubled it to give us 0.02, and doubled that to get 0.04, right? So if you put in the first 3 values of a table, and you know they're multiplying each time, make sure you press enter so you're down here below it. And now we're going to do very similarly. Hit menu, 4 for statistics, 1 for stat calculations. But we know it's not linear, right? So we're not going to do 4, 1, 3. We need to do exponential, which is 4, 1, A. Does everyone see that? So menu 4, 1, A, letter A. X has to be X. Y has to be Y. Whoops. X. Y. 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 Just press Y. Hit enter. Is R squared 1? We know we did it right. Cool? So, now this is kind of weird. It says A times B to the X power. Okay? A times B to the X power. A is 0.005. B is 2. So we're going to write this equation, replacing A with 0.005 and B with number 2. So let me show you how we write this. Ooh, how about them Cowboys? So Y equals, and the first number was 0.005. That's my A. My second number, I'm going to hit parentheses and put that 2, and the exponent was X. So I want you to see it on the calculator. The first number was A, the second number is B, and then we had to the power of x, okay? A times b to the x. A times b to the x. Cool? So 0.005, parentheses 2 to the power of x. What does each number mean? So 0.005, I'm going to tell you, if you didn't already know this, the A, the number you start, the first number in the regression is the starting value, okay? So or the starting amount is what we called it on the last one. Starting amount. Now, that might seem weird. The first day we got paid a penny, right? But the starting amount is at 0. So half of a penny is 0.005, okay? So half a penny is what you start off with at day 0. Day 1, you get paid 1 penny. You've doubled. Okay, now, what do you think this 2 means? What are we doing each time? We're multiplying by 2. So that's the changing amount. That's the multiplier, okay? So we can call it the changing value. Just finish this one real quick. Changing value / multiplier. Okay? Now we're going to stop right there because we're going to use this information tomorrow to do these regressions. So off to the side, write menu 41A. So you have that written down for your notes.